I did not overhaul my diet, extend my workouts, or chase a new trend. I simply introduced 5 quiet grams of a single substance into my daily routine, and over time my body began to respond in ways that felt almost deliberate. Chronic inflammation softened, stored fat slowly released its grip, and muscle awakened as if a long-missing signal had finally arrived, reminding me that the human body does not resist change. It waits for the right biological conversation to begin. The human body is often misunderstood as a machine that responds best to force, pressure, and dramatic inputs, but biology tells a quieter and more patient story. At the cellular level, change does not come from shock. It comes from repetition. Every cell lives in time, not urgency. It listens not to what we do once, but to what we do again and again. A single extreme action may trigger a stress response, but a consistent signal rewires expectation. Cells adapt based on patterns, not events. This is why the body can survive chaos yet only transforms through rhythm. When a biological system receives an intense stimulus, it does not assume permanence. It assumes danger. Sudden restriction, excessive training, or extreme supplementation is interpreted as instability. In response, the body protects itself. Hormones shift toward conservation, inflammation rises to guard tissue, and energy expenditure becomes cautious. This is not failure. It is intelligence. The body evolved in environments where extremes often preceded scarcity or injury. It learned to defend first and optimize later. Consistency, on the other hand, tells a different story. When a signal appears every day at roughly the same intensity, the body stops questioning its reliability. At the cellular level, reliability equals safety. Safety allows investment. Once cells believe that energy, nutrients, and recovery will continue to arrive, they redirect resources away from emergency responses and toward repair, growth, and efficiency. This shift is subtle but profound. It is the difference between surviving and adapting. Muscle tissue is a powerful example of this principle. Muscle does not grow because it is forced to suffer. It grows because it is repeatedly shown that stress will be followed by nourishment and recovery. One brutal workout does not convince muscle to expand. A repeated cycle of manageable stress and reliable support does. Over time, muscle cells increase protein synthesis not because they are threatened, but because the environment feels predictable enough to justify expansion. Inflammation follows the same logic. Acute inflammation is a short-term response to perceived danger. Chronic inflammation emerges when the body senses unresolved uncertainty. Erratic sleep, inconsistent nutrition, and fluctuating energy availability keep immune signaling slightly elevated, always preparing for the next problem. When daily inputs become stable, inflammation no longer needs to stay on alert. It quiets naturally, not because it was suppressed, but because its job is no longer required at the same intensity. Fat storage is also governed by consistency. Fat cells do not accumulate energy because the body is careless. They do so because the future feels unreliable. Inconsistent caloric intake, dramatic dieting, and sudden overfeeding teach the body that supply cannot be trusted. Fat becomes insurance. When the body receives steady signals of adequate energy over time, that insurance becomes less necessary. Fat loss then occurs not through conflict, but through reduced need. What makes consistency so powerful is that it aligns with how biological memory works. Cells remember trends. They alter gene expression, enzyme activity, and hormonal sensitivity based on repeated exposure. This is how habits shape physiology. 5 grams taken daily sends a clearer message than 50 grams taken occasionally. The body is not impressed by magnitude. It is persuaded by continuity. There is also an emotional dimension to this biological truth. Humans are drawn to extremes because they promise rapid change and emotional payoff. Consistency feels slow, almost invisible. Yet the body values patience more than passion. It responds to what is dependable. When daily behaviors become predictable, stress hormones gradually decline, recovery improves, and energy allocation becomes more efficient. The nervous system itself begins to relax, reinforcing the same adaptive loop at a higher level of organization. Scientific research repeatedly confirms this pattern across systems. Bone density responds to repeated loading, not rare maximal force. Insulin sensitivity improves with regular movement, not occasional exhaustion. Mitochondria increase in number and efficiency through sustained energy demand, not sporadic intensity. Adaptation is a cumulative process, built layer by layer through repetition. This understanding reframes health entirely. It suggests that transformation is not about overpowering the body, but about earning its trust. Each consistent action is a vote for stability. Over time, those votes accumulate until the body changes its internal expectations. It begins to behave as though the environment is supportive rather than hostile. When people say their body is resistant, what they often mean is that their signals are inconsistent. The body is not stubborn. It is cautious. Once caution is no longer necessary, cooperation emerges. Strength increases without strain. Inflammation fades without suppression. Metabolism accelerates without force. These outcomes feel almost effortless because the work was done quietly, day after day, at a level the body could accept without fear. Consistency also preserves resilience. Extreme approaches often deliver short-term results followed by regression, because the body never truly adapted, it only reacted. Consistent signals, however, create durable change because they alter baseline physiology. The new state becomes normal rather than maintained through effort. This is why small daily practices often outlast grand interventions. In this light, 5 grams a day is not a dose. It is a message. It tells the body that support is present, that energy can be used rather than hoarded, that repair is worth the investment. Over weeks and months, that message becomes belief, and belief becomes biology, shaping how cells allocate resources, how tissues respond to stress, and how the entire system expresses strength, balance, and adaptability over time. Inflammation is often spoken about as if it were a flaw in the body, an enemy that must be silenced or eliminated. But this view misunderstands its origin and its purpose. Inflammation is not a mistake. It is a language. It is the body's way of signaling uncertainty, stress, or perceived threat at the cellular level. When tissues sense that their environment is unstable, unpredictable, or insufficient, inflammation rises as a protective response. It mobilizes resources, heightens alertness, and prepares the system to survive potential damage. In this sense, inflammation is not something that suddenly appears without reason. It is the visible expression of an internal question the body has not yet answered. Energy uncertainty sits at the center of this question. Every cell operates under strict energetic rules. Repair, growth, and optimization are expensive processes. They require not just calories, but reliable access to them. When energy availability feels inconsistent, cells shift priorities. They favor defense over development. Inflammation becomes part of that defensive posture, keeping immune signaling active in case tissue damage or infection arises during periods of scarcity. This is not pathology. It is evolutionary logic. Chronic inflammation, then, is rarely the result of a single trigger. It emerges when the body receives mixed signals over time. Erratic eating patterns, inconsistent sleep, fluctuating stress levels, and unpredictable physical demands all contribute to an internal environment where cells cannot confidently plan ahead. When the future feels uncertain, inflammation stays present, not aggressively, but persistently, like a low hum of vigilance that never fully shuts off. What is striking is how often inflammation is treated directly, rather than contextually. Anti-inflammatory strategies frequently focus on suppression, attempting to quiet the signal without addressing why it was raised. While this may reduce symptoms temporarily, it does not resolve the underlying message. The body continues to sense uncertainty, and inflammation quietly returns. The signal was never the problem. The conditions that produced it were. Energy sufficiency changes this conversation entirely. When cells begin to sense that fuel is consistently available, their behavior shifts. Mitochondria operate more efficiently, stress hormones decrease, and immune signaling recalibrates. Inflammation does not need to remain elevated because the perceived risk has diminished. The body no longer feels the need to stay on guard. Calm emerges not through force, but through reassurance. This is why inflammation often decreases not when people try harder, but when they stabilize their routines. Regular nourishment, predictable movement, and adequate recovery create an environment where cells feel supported. Over time, inflammatory markers decline naturally. The immune system remains capable, but it is no longer restless. It stands ready rather than tense. Muscle tissue plays an important role in this process. Active muscle improves glucose handling, increases insulin sensitivity, and acts as a sink for excess energy. When muscle is metabolically engaged and adequately fueled, it reduces the metabolic chaos that often fuels inflammation. This does not require extreme training. It requires consistency. Muscle activity sends a message that energy is being used productively rather than wasted or hoarded, further reducing the need for inflammatory signaling. Fat tissue also participates in inflammatory communication. When fat cells expand rapidly or unpredictably, they release inflammatory signals as a call for attention. This is not because fat is inherently inflammatory, but because rapid energy storage reflects uncertainty. When energy intake and expenditure stabilize, fat tissue becomes metabolically quieter. Inflammation subsides as the system regains balance. Stress adds another layer to this dynamic. Psychological stress is translated biologically through hormonal pathways that directly influence inflammation. Chronic stress signals unpredictability, even if physical resources are abundant. The body does not distinguish between emotional and physical threats. Both contribute to perceived instability. When stress remains unresolved, inflammation persists, reinforcing fatigue, discomfort, and metabolic dysfunction. Understanding inflammation as a signal of uncertainty reframes how we approach health. Instead of asking how to eliminate inflammation, the more productive question becomes what conditions are causing the body to remain uncertain. Often, the answer lies not in rare toxins or obscure disorders, but in daily patterns that lack rhythm and reliability. Consistency again emerges as the quiet solution. When the body receives steady cues of safety, energy sufficiency, and recovery, it gradually releases its defensive posture. Inflammation decreases not because it is forced down, but because it is no longer necessary at that level. The immune system remains intelligent, responsive, and precise, rather than broadly activated. This perspective also encourages compassion toward the body. Inflammation is not betrayal. It is communication. It is the body saying it does not yet trust the environment enough to relax. When that trust is earned through stable inputs, inflammation softens as a natural consequence. Healing, in this sense, is not about control but about restoring confidence at the cellular level. Over time, as uncertainty fades, the body reallocates energy toward repair, regeneration, and strength. Tissues recover more quickly. Pain diminishes. Metabolic processes become smoother. None of this happens abruptly. It unfolds gradually, in response to repeated reassurance that the system is safe, supported, and no longer required to live in a constant state of readiness. Muscle is commonly viewed as a structure built for movement, strength, or appearance, but this perspective captures only a fraction of its true role in human biology. Muscle is not passive tissue waiting to be commanded. It is an active communicator, constantly exchanging information with the rest of the body. Every contraction, every period of rest, every moment of recovery sends biochemical signals that influence metabolism, immunity, and energy allocation. In this sense, muscle functions less like machinery and more like a regulatory organ, shaping how the body decides to store, release, or utilize energy. At the metabolic level, muscle acts as one of the largest energy consumers in the body. It requires glucose, fatty acids, oxygen, and amino acids not just to move, but to maintain its internal structure. Because of this demand, muscle becomes a primary negotiator in the body's energy economy. When muscle is active and adequately supported, it signals that energy is being put to productive use. This alone changes how the body interprets abundance and scarcity. Energy that is actively used feels safer than energy that accumulates without purpose. These signals extend far beyond the muscle fibers themselves. Contracting muscle releases molecules that travel through the bloodstream and influence distant tissues. These signals inform the liver about glucose production, the brain about energy availability, and the immune system about the body's overall state. When muscle engagement is consistent, these messages tend to promote balance rather than defense. The body shifts toward regulation instead of reaction. Inflammation is deeply affected by this communication. When muscle is metabolically inactive or underused, energy begins to stagnate. Blood sugar regulation becomes less precise, lipid handling grows inefficient, and immune signaling becomes more vigilant. In this state, inflammation often rises not because something is damaged, but because the system lacks clear direction. Muscle inactivity creates informational silence, and the body fills that silence with caution. As muscle becomes more engaged, the opposite occurs. Improved glucose uptake reduces metabolic stress, lowering the signals that often provoke inflammatory responses. Energy flows more smoothly through the system, reducing the need for immune overactivation. Inflammation recedes not because it is suppressed, but because the underlying conditions no longer justify its presence. Fat tissue responds closely to this shift. Muscle and fat exist in constant conversation, each responding to the other's behavior. When muscle signals that it can handle incoming energy, fat storage becomes less urgent. Energy no longer needs to be locked away for future emergencies. Fat cells begin to release stored energy more willingly, and their own inflammatory signaling diminishes as a result. This relationship explains why muscle development often precedes sustainable fat loss. It is not merely that muscle burns more calories. It is that muscle changes the body's interpretation of energy security. A body with metabolically active muscle perceives abundance differently. It feels capable of managing energy flow, reducing the need for excessive storage. Muscle also influences hormonal environments. Active muscle improves sensitivity to anabolic and regulatory hormones, creating conditions where nutrients are directed toward repair and growth rather than storage. This hormonal clarity reduces internal noise, further calming inflammatory pathways. The system becomes more efficient, more precise, and less reactive. What is particularly striking is that muscle does not require extreme stimulation to perform this role. It responds to regular, moderate signals that it can trust. Repeated engagement, followed by adequate recovery and nutrition, establishes a rhythm that the body learns to rely on. Muscle then becomes a stable reference point, signaling reliability in an otherwise fluctuating environment. This stability affects the nervous system as well. The brain interprets consistent muscular activity as a sign of capability and preparedness. Stress responses soften. Cortisol rhythms stabilize. The body no longer feels compelled to remain in a defensive posture. In this way, muscle indirectly contributes to psychological calm, reinforcing the same metabolic and inflammatory benefits from another angle. From an evolutionary perspective, this makes sense. Muscle represented survival capacity. A body capable of regular movement, lifting, and endurance signaled readiness for environmental demands. Such a body could afford to invest in repair and strength rather than constant vigilance. In modern contexts, where physical demands are often inconsistent, muscle engagement restores a sense of biological credibility to the system. This understanding reframes training entirely. Exercise becomes less about forcing adaptation and more about restoring communication. Each session is a message, not a punishment. When those messages are consistent and supported, muscle responds by amplifying its regulatory role. It becomes an ally in metabolic balance rather than a tissue struggling under stress. As muscle grows stronger and more metabolically active, its influence compounds. Energy handling improves, inflammation quiets, fat becomes more flexible, and recovery accelerates. These changes feel interconnected because they are. Muscle sits at the crossroads of these systems, coordinating rather than dominating. Over time, this coordination reshapes how the body expresses health. Strength emerges without constant strain. Body composition shifts without desperation. Inflammation fades without suppression. Muscle does not demand these outcomes. It facilitates them by acting as a clear, consistent communicator within the biological network, guiding energy where it is needed most and calming the systems that once felt compelled to defend, conserve, or overreact. Fat is often framed as a failure of discipline or a metabolic flaw, yet from a biological perspective it is neither. Fat is a strategy. It is the body's way of preparing for uncertainty, a form of stored reassurance built during times when future energy availability feels unreliable. Long before modern lifestyles, fat represented survival. It allowed the body to bridge gaps between food access, illness, injury, and environmental stress. That logic has not disappeared. It still governs how fat tissue behaves today. When the body perceives instability, fat storage increases. This perception does not require actual starvation. It can be triggered by erratic eating patterns, inconsistent caloric intake, irregular sleep, chronic stress, or unpredictable physical demands. The body does not measure intention. It measures patterns. If energy arrives in bursts and disappears without warning, the system learns to prepare. Fat becomes insurance, a biological savings account designed to protect vital organs and maintain function during uncertain times. This is why aggressive dieting often backfires. Severe restriction signals danger, even when food is technically available. Hormonal shifts follow, reducing metabolic rate and increasing hunger signals. Fat cells become more defensive, less willing to release stored energy. The body interprets restriction as a warning, not a solution. In this context, fat is not stubborn. It is vigilant. Fat tissue is also hormonally active. It communicates with the brain, immune system, and metabolic organs through chemical signals that reflect its perception of safety or threat. When fat tissue senses rapid expansion or forced depletion, it increases inflammatory signaling, reinforcing a defensive state. This creates a feedback loop where stress promotes storage, and storage reinforces stress. Security changes this dynamic. When energy intake becomes steady and predictable, fat tissue receives a different message. It begins to trust that future needs will be met without extreme measures. As that trust develops, fat cells loosen their grip. Energy release becomes easier, inflammatory signaling diminishes, and metabolic flexibility improves. Fat loss in this context is not forced. It is permitted. This process requires time because trust is built slowly at the cellular level. Fat cells respond to trends, not intentions. A few days of adequate intake cannot override months or years of perceived instability. Consistency must persist long enough for fat tissue to revise its expectations. Once that shift occurs, the body no longer treats stored energy as sacred. It becomes usable again. Muscle plays a key role in reinforcing this sense of security. Active muscle provides a reliable destination for energy. When fat tissue sees that energy is being used productively rather than wasted or lost, its need to hoard decreases. This inter-tissue communication shapes how the body allocates resources. Fat does not exist in isolation. It responds to the overall metabolic environment. Stress further complicates fat behavior. Psychological stress is interpreted biologically as environmental threat. Elevated stress hormones signal unpredictability, even in the presence of sufficient calories. Fat tissue responds accordingly, increasing storage and resisting release. This explains why fat loss often stalls during periods of emotional or cognitive strain, regardless of diet or exercise. The body prioritizes preparedness over aesthetics. Sleep also influences perceived security. Inadequate or irregular sleep disrupts hormonal rhythms that regulate hunger, energy use, and fat storage. From the body's perspective, poor sleep signals instability in the environment. Fat accumulation becomes a rational response. Restoring sleep consistency often produces metabolic changes without any other intervention, reinforcing the idea that fat responds to context more than control. Understanding fat as protective reframes how change occurs. Fat does not need to be fought. It needs to be reassured. When the body senses that energy will continue to arrive, that recovery will occur, and that stress is manageable, fat storage loses its urgency. The body begins to operate in a mode of sufficiency rather than defense. This also explains why gradual approaches outperform extreme ones over time. Slow, Steady changes give fat tissue time to adapt without triggering alarm. Weight loss achieved through consistency tends to persist because the underlying perception of security has changed. The body no longer feels the need to reclaim what was lost. There is a psychological relief in this understanding. It removes moral judgment from body composition and replaces it with biological logic. Fat is not a personal failing. It is a memory of uncertainty. When that memory fades, fat behavior changes accordingly. The body responds not to shame or force, but to stability. In modern life, where signals are often mixed and rhythms disrupted, fat becomes a visible marker of hidden instability. Addressing that instability requires less aggression and more structure. Regular meals, consistent movement, adequate rest, and manageable stress levels create an environment where fat storage becomes unnecessary. As the body settles into this environment, subtle shifts occur. Hunger cues normalize. Energy levels stabilize. Cravings soften. Fat loss emerges as a side effect rather than a goal. The system moves from guarding resources to circulating them. Over time, the body learns a new baseline. Fat tissue no longer expects scarcity. It becomes metabolically quieter, less inflammatory, more responsive. Energy flows more freely between storage and use. This transition is not dramatic, but it is profound, reflecting a deeper change in how the body interprets its world and its future. True physical transformation does not emerge from domination of the body, but from cooperation with its underlying logic. The body is not an object to be corrected. It is a living system designed to protect itself, adapt intelligently, and conserve resources in uncertain conditions. When people attempt to force change through extremes, they often mistake resistance for weakness, when in reality it is caution. The body does not oppose improvement. It evaluates risk. Cooperation begins when actions align with that evaluation rather than trying to overpower it. Biology is built around trust. Cells are constantly assessing whether their environment is stable enough to justify investment in growth, repair, and strength. When inputs are erratic, the body defaults to survival mode. Energy is conserved, inflammation stays active, and progress slows. Force amplifies this defensive posture. Cooperation, however, lowers the body's guard, communicates safety, reliability, and continuity. In that state, transformation becomes a natural response rather than a coerced outcome. This is why sustainable change often feels quieter than expected. There is no dramatic moment where the body suddenly surrenders. Instead, there is a gradual softening. Recovery improves without conscious effort. Strength increases without constant strain. Fat loss occurs without obsession. These changes are not imposed. They are allowed. The body begins to express capabilities that were always present but previously restrained by uncertainty. Cooperation requires understanding signals rather than chasing outcomes. Training becomes a way to communicate capability, not to inflict punishment. Nutrition becomes reassurance, not restriction. Rest becomes a biological necessity, not a reward. When these elements work together, the body stops defending against change and starts participating in it. The system shifts from protection to optimization. Scientific curiosity plays a critical role in this shift. Curiosity encourages observation instead of judgment. It invites questions like why the body responds the way it does, rather than how to make it obey. This mindset transforms health from a battle into a study. Each response becomes information. Fat gain signals insecurity. Inflammation signals overload or uncertainty. Fatigue signals insufficient recovery. When these signals are respected rather than suppressed, the body responds with cooperation. The nervous system is especially sensitive to this approach. Chronic stress, both physical and psychological, tells the body that the environment is hostile. In that context, even well-intentioned health behaviors can be interpreted as additional threats. Cooperation calms the nervous system by reducing unpredictability. Predictable routines, manageable effort, and consistent recovery create a sense of safety that cascades through hormonal and metabolic pathways. This safety allows energy to flow differently. Instead of being locked away or rationed, Energy is allocated toward rebuilding tissue, strengthening muscle, and improving efficiency. The body stops asking whether it needs to prepare for disaster and starts planning for continuity. This shift is subtle but transformative. It changes how the body prioritizes every process. Muscle growth under cooperative conditions feels different. It is less inflammatory, more sustainable, and less exhausting. Fat loss feels less like loss and more like redistribution. Inflammation fades without suppression. Sleep deepens. Appetite becomes clearer. These are not separate achievements. They are expressions of the same underlying agreement between behavior and biology. Compassion toward the body strengthens this agreement. When people stop framing their physiology as flawed, compliance improves at every level. Stress decreases. Recovery accelerates. The body is no longer fighting against judgment layered on top of physical demand. Cooperation thrives in an environment free of hostility. Over time, this approach reshapes identity. Health is no longer something pursued aggressively, but something maintained attentively. The body becomes a partner rather than a project. Progress feels less urgent and more reliable. The need for extremes fades as the system stabilizes. This does not mean effort disappears. It means effort is applied intelligently, in doses the body can integrate without alarm. Consistency replaces intensity. Understanding replaces frustration. Biology rewards this alignment with resilience rather than rebellion. What ultimately emerges is not just physical change, but a deeper coherence between intention and physiology. The body begins to express strength, balance, and efficiency as default states rather than temporary achievements. Transformation unfolds not because the body was conquered, but because it was finally understood well enough to be trusted, supported, and allowed to do what it evolved to do when conditions make sense.